take a look at HSS-CP.A.4. And this is about the introduction of a two-way frequency table and the use of it to organize data. And it's a very powerful tool and a very clear one to use to help students gain understanding of probabilities. So you're basically going to construct one, either given some data or filling in some blanks or going out gathering data and then making your own two-way table. But from the two-way table, you're going to determine a bunch of things about, what's the probability of this happening, or what's the chances of this happening given that that has happened? What's the chances of, anything from that table, I guess, just asking questions about probabilities. It can be conditional probabilities, it can be just normal ones or whatever. And then from that two-way table, assessing independence of those events. Is the intersection equal to the probability of A times the probability of B, things like that. This actually, for me, I slide this down a little bit, not because of difficulty, but because I like to use it to review all of the concepts. So I like to have handled independence and conditional probabilities and or statements and statements and all of that first. And then when I get here, it works out nicely to be a nice review of that. The one area, I guess, in terms of traps and pitfalls that just comes to mind quite quickly is the idea that when you have a two-way table, and I will just create some things, those that said yes, those that said no, boys, girls. Actually, yes, no may not work. So let's pick colors blue and green. They're determining I don't know, colors of cars or whatever. 3 boys picked that, 7 girls picked that. There's 10 in here. 9 boys picked green and 3 girls picked green as well. So we get 12 here, 22 in total. We get 10 here. Now, a couple of things, whoa, this is messy. Going fast here though to save time. So you can see the sums. This area is known as the joint probabilities because they're counting in more than one row and column. These out here are called the marginal probabilities. So what's the chances of a boy picking, or what's the chances of a boy picking blue? 3 out of 22. What's the chances that you're a boy in this group? 12 out of 22. What's the chances of being a girl that picked green? 3 out of 22. Now, here we go. Given that it was a boy, what's the chances you picked blue? 3 out of 12. I love how the conditional probability isolates one row or one column. And it's very clear what's going on. Oh, I already knew it was a boy. It's not out of everything now. It's only out of 12. Chances of blue are 3 out of 12. I'm leading to the trap. The typical trap is the or statement. What's the probability of blue or a boy? And what happens here is they say, oh, probability of blue is 10. Probability of boy is 12. 22 out of 22 out of 22, and you're like, just like I did, I went, huh? Something wrong there. But guess what? This guy got counted twice. So you can't count that one going this way and it again, so it's 19 out of the 22, because it's the sum of these, 22, minus that intersection, because you used it twice. Anyways, that's for a later objective, but this is one that I say that is one of the typical pitfalls.